representation of control systems is signal flow diagrams or signal flow graphs. Besides the block diagrams, they are mostly used for state space representation in the time domain representation. They are pretty easy. Just we are showing different kind of diagram of the system. In this case, blocks G's, that is transfer function G's, are shown with flows, and signals are shown with like circles. For example, in this case, VS, the signal VS here, is R1S G1S. They multiply minus R2S G2S plus R3S G3S. And we can say, for example, C1, the output C1, controlled variable C1 is G4 VS, or C2 is G5 VS, or C3 is minus G6 VS. So the same idea of multiplication happens for the signal flow. Let's understand this by representing a block diagram, converting block diagram to a signal flow graph based on cascade form. In cascade form, so we have these signals like R, we have X2, we have X1, and we have C. So the reason we are naming these guys from right to left, that is X1 and X2, will be discussed in the state space representation, but learn it like this. So X1, X2 is not very acceptable. So this flow is like G1, this flow is G2, and this flow is G3. So in the cascade form, T equal to CS over RS is G1, G2, G3. They just multiply to each other as we had for the block diagrams. If we have parallel form, so here we have signal RS and we have signal CS. So R comes to a flow like this and gives us X1 by G1. We have X2 signal and X3 signal, and this guy is G2 and this is G3, and they just sum plus minus 1, plus minus 1, and plus minus 1. So the parallel form in which we sum the signals together. So the transfer function of this system is G1 plus minus G2 plus minus G3. And if we have a feedback system, we have this signal R input, signal C as the control variable output. We have E as error or actuating signal here. So E goes to C by G, and we have this guy H flow, and this guy is plus 1. So H is plus minus 1 in this case, or minus plus 1. It's written minus plus 1. So this is converting from block diagram to signal flow graph for a feedback system. We learned that how we can simplify block diagrams, like the rules of cascade, like if we have G1, G2, we can simplify them as G1, G2, Or if we have something like this, what is the transfer function for this guy? It's like feed forward G over 1 plus minus open loop GHS, open loop transfer function. And this guy is closed loop transfer function. This guy is feed forward transfer function. This guy is open loop transfer function. For the signal flow graphs, for example, you have this signal flow graph, okay? You want to make it simple. You want to simplify this as something like this, as a transfer function, and you have R and you have C. You can use the same idea like what we did in block diagrams, but there is this rule called Mason's rule, which we have to know in order to simplify complicated signal flow graphs. First of all, it says that I want to show it with an example step by step. First says that find the loop gains. What are loop gains? The product of branch gains found by traversing a path that starts at a node and ends at the same node, following the direction of the signal flow without passing through any other node more than once. For example, here we have a loop. So loop gain 1 is G2 H1. Then we have another loop here, this guy. Or this guy we have here. The second one is G4 H2. And the third one is G4 G5 H3. And also we have this loop starting from here, and it's like G6 H3 G4. So for this system we have 4 loop gains. Okay, then it says that find forward path gain. Forward path gain means start from the input to output and go the way not repeating any. Like if you go just straight this way, the first forward path gain is G1, G2, G3, G4, G5, G7, G7. And the second one is like going this way and going from up. That is like second one is G1, G2, G3, G4, G6, G7. This is the second step. So after finding the loop gains, you find the forward path gains. Then the third step is working on these loop gains. Let me bring these here. We have these loop gains. We have to find subsets that are not touching each other. 2 and 3 subsets. For example, this is the blue one. This is the red one. This is the green one. This is the orange one. Okay? I can say that 1 and 2 are not touching each other. 1 and 3 are not touching each other. And 1 and 4 are not touching each other. But 2 and 3, 3 and 4, they are touching each other. Means they have some nodes and flows that are in common. They are not non-touching. So we find 3 of them. Then non-touching loop gains is like you have 1, 2, that is you have to multiply 1 and 2 together. That is G2, G4, H1, H2. Then you have 1 tree that is G2, H1, G4, G5, H3. So I'm writing them based on this, guys. These are the loop gains. So if I want to write the 1, 4, I will have G2, G4, G6, H1, H3. This is multiplication of these non-touching loop gains. So after we find these, we have this Mason's rule. The rule says that if K is the number of forward path and Tk is the forward path gain, you calculate the summation of Tk multiplied by delta K, in which delta K is delta minus something. What is delta? Delta is 1 minus loop gains plus non-touching loop gains taken 2 at a time, and then again minus taken 3 and plus taken 4. I will show it with an example, okay? It seems very complicated, but with an example, I can explain exactly what is this relationship. Let's look at this guy, okay? What should I do? First, I find the loop gains. I have this loop here. One is G2, H1. I have the second loop here, G4, H2. I have the third loop here, which is G2, G3, G4, G5, G6, G7, G8. And I have this guy here, loop 4, which is G7, H4. Now I have to see what are non-touching. 1 and 2 are non-touching. Then 1 and 4 are non-touching. And then 2 and 4 are non-touching. And also I have 1, 2, and 4 non-touching. So 3 is touching every loop here. So they have, this is 3 that is touching, that is has common with everything. So 3 put it aside, but you have this 1 not touching 2, 1 not touching 3, 4, sorry, and also 2 not touching 4, and also these 3 guys not touching each other. So these are subsets, 2 and 3. So what is delta? First, I have to write T. T is feed forward. This is T. G1, G2, G3, G4, G5. So transfer function is T1. I have just one feed forward transfer function, delta 1 over delta. What is delta? Delta says that 1 minus loops, that is G2, H1, minus G4, H2, minus G2, G3, G4, G5, G6, G7, G8, minus G7, H4, okay? And we can say like this, we can put it like this. Then I have to plus subsets of 2. Subsets of 2 means plus 1 and 2. 1 and 2 is G2H1, G4H2. Then 1 and 4 is G2H1, G7H4. Then 2 and 4, that is G4H2, G7H4. And then we minus it by subset taken 3, that is 1 to 4. 1 to 4 is G2H1, G4H2, G7H4, plus taken 5, taken 4. There is no taken 4, so nothing. Okay? So this is the definition of delta. Delta says that 1 minus loop gains plus non-touching loop gains taken 2, that is, for example, 1, 2, 1, 3, I don't know, 2, 3. Then minus loop gains taken at 3 times. For example, 1, 2, 3, or 4, 5, 6. And it continues. Plus loop gains taken 4 times. For example, 1, 2, 3, 4, if they are non-touching. And delta K means delta, we have the delta, minus loop gain terms in delta that touch the feed-forward path. So delta 1 means delta with 0 parts zeroing, let's say with zeroing parts that make touch, that let's say touch T1. So this is delta when everything is 0 except the G7H4, because just this guy is not touching the feed forward. Here, this feed forward is touched by this guy. This feed forward is touched by this guy. This feed forward is touched by this guy. And this feed forward is not touched by this one. So in delta, you put every touching 0, 0, 0. Just this remains 0, 0, 0, 0. Because these guys are touching, this part is touching the feed forward. So you just remain with this guy. You have delta, you have delta 1, you have T1, you find the transfer function GS. Any question? No question? Okay, please also try to find these transfer functions of the examples. I have given the answer to them. They are the same as the problems we solved today. And also go to the practice at home and study, solve the examples and solve the skill assessment. And we have also question 3, 4, 5, 6, 7 for block diagrams, and 8 using Mason's rule.